Welcome to 2D kinematics. When we talk about 2D kinematics, we actually talk about trigonometry. In fact, trigonometry is the language of 2D kinematics. It is impossible to solve 2D kinematics problem without trigonometry. Trigonometry is I believe trigono is the angles and metry is the measurement. So in Greek, trigonometry means the measurement of angles. That makes sense because it was invented by a Greek philosopher named Hipparchus. So Hipparchus invented trigonometry some 2200 years ago to solve physics problem. We still use trigonometry today to solve physics problem. When we actually start our trigonometry conversation, we start it with SOHCAHTOA. And we usually start our conversation with a right triangle. So when we draw a right triangle, we put an angle and we try to see all the side with respect to that angle. So I'm going to put an angle and I'm going to look at all the side, all three sides with respect to this angle. All right. So if I look the other side, I'm going to call them opposite, and that makes sense because it's opposite to the angle. If I look to the nearest, the closest side, I'm going to call it Jason, because there's the convention, it is called Jason. And if I look the longest side, and that's what I call hypotenuse, because this is convention to call it hypotenuse. Now I have the trigonometric ratios. Now I can write them down using the numeric SOHCAHTOA. Let's start with so sine theta. So this is sine theta. So the sine theta is opposite over hypotenuse. So opposite over hypotenuse. This is nothing but a fraction. It's a fancy way of, it's a different way of writing fractions. So when you see sine, don't get freaked out, because when we talk about this, we actually talk about fraction. I'm sure you've seen fraction before. So cosine theta is equal to Jason, which is Jason over hypotenuse, and tangent theta is opposite over Jason. Tangent theta, you can another way of calling tangent theta is slope, or you can call it rise over run. Now there are 6 trigonometric identities. I wrote 3. I can definitely write 3 more. So now this is cosecant, cosecant theta, this is secant theta, and this is cotangent theta. So cosecant theta is hypotenuse over opposite, and secant theta is hypotenuse over Jason, and cotangent theta is Jason over opposite. Now when we talk about the trigonometric identities, we always expanded our conversation and push it to the unit circle. Why do we do that? Is because that allows us to understand it better. So now let's draw the unit circle. What makes it a unit circle? The radius is 1. That makes it unit circle. So let's divide this in 4th quadrant 1, 2, and 3, and 4, and we're gonna call the radius 1, and that makes it, this is the radius and this is 1, that makes it a unit circle. Now when we measure any angle in the unit circle, we do it with respect to x, we do it with respect to s, and then we always do it counterclockwise. So what do we mean? I mean, if I have an angle, so if I want to draw an angle, I do it from x-axis counterclockwise. All right, so I'm going to call it, for example, theta. So this is the same as this one. If it is in unit circle, so I do start measuring it doesn't have to be 30 degree, it doesn't have to be 60 degree or 45 degree, it could be any. Oh wow, so when we talk about the degree, we actually sometimes use the degree. So how do we measure it? How do we measure the angles? We use the degrees, and sometimes we use the radians. So how do you measure the angles? Degrees. So degrees, how do you measure the degrees? You start from the x-axis, you go counterclockwise, and that's how you measure the degrees. And degree is always from 0 to 360. All right, so 3 from 0 degree, so you use the degree 3 to, and the radian is start from 0. You don't use the degree for radians, to 2 pi. So what are we talking about? So this is 0 degree. So then what is 0 degree? This is 0 degree, this is 90 degree, this is 180 degree, this is 270 degree, and back to 360 degree. And sometimes you use the radian instead of degree. So this is 0 degree, this is 180, this is pi, this is pi over 2 or 90 degree, and this is 3 pi over 2, and this is 2 pi. Let's say you forgot that whether this is 3 pi over 2, or you know this is 270. How can you figure that out? So you have 270 degree times, now you need the radian, so you put the radian on the top, you put the degree on the bottom. So 180 degree, and you put the pi on the top. So now 0 0 cancel, 6 goes to 18 3 times, and let's divide it by 9. 9 goes to 18 twice, and 9 goes to 27 3 times. So 3 pi over 2 and 3 pi over 2. That's exactly what I wrote. So you can absolutely do it this way. Now another thing that we do, we write the trigonometric identities in terms of the unit circle, and let's do that. And you have an acute triangle. So this is what you call radius. So this is the radius. This is your x, and this is your y. All right, so now let's write the SOHCAHTOA in terms of x, y, and radius, and let's see how you get that. So if you do that, then what do you get? Sine theta is opposite, which is opposite over hypotenuse. So opposite is y over r. So I'm going to write it over here, and I'm going to write it different color, y over r. And let's write the cosine theta. Cosine theta is adjacent over hypotenuse. So adjacent is x, and hypotenuse r, so x over r. And tangent is opposite over adjacent. So opposite is y, and adjacent is x, so y over x. And now since we have this, we can write the remaining 3 trigonometric identities, and this would be cosecant would be r over y, and secant would be r over x, and tangent would be x over y, and cotangent would be x over y. So this is opposite is y over x, so the tangent is cotangent is x over y. So no wonder why we call it slope. All right, now let's consider three angles, 3 most famous right triangles. So 3 most famous right triangles, I'm going to write them right here. 3 most famous right triangle. So the first one, I'm going to call it 30, 60, and 90. The second one I'm going to call 45, and 90. The third one I'm going to call 60, 30, and 90. 90 you don't have to write, this is a right angle. So what do we have it over here? We're gonna write the ratio. So the opposite to the angle is always the smallest one, and this is the opposite to the 90 degree is always the bigger one, 2x, and opposite to the 30 is always the small one, x, and opposite to the other angle, which is 60, is x square root of 3. Now you can prove that. So now c square is equal to a square plus b square. By Pythagorean theorem you can prove that. So c square is 2x square is equal to a square, which is x square, plus b square, which is x root 3 square. So this is 4x square is equal to x square plus 3x square. So 4x square is equal to 4x square. Check. This one is very important for physics. This you call x, this you call x, this is you call x root 2. You also can prove it by c square equal to a square plus b square. So the c square is x root 2 square is equal to x square plus x square. So this one 2x square is equal to 2x square. Proof. This you have 30 over here, so the smallest, which is x, and 90 over here, the largest side, and then this is x root 3. And you can use the Pythagorean theorem to prove it. A square plus b square equal to c square. A square is x root 3 square plus b square is x square plus c is equal to c square is 4x square. So this is 3x square plus x square is 4x square. Proof. Okay. Now you don't have to do you can do the same thing with the unit circle. How can you do that? Let's do this. If you do have unit circle, and you can divide the first quadrant in three slices. So let's cut the first quadrant in 3 slices. All right. So each and every point is x comma y, or cosine theta comma sine theta. So this point is cosine theta comma sine theta, or cosine is x and sine is y. Now this is 30 degree angle, this is 45 degree angle, this is 60 degree angle. All right. So this one is cosine theta comma sine theta. This one is also cosine theta comma sine theta. This one also cosine theta comma sine theta. All right. Another way of saying this one is x, this one is y. Another way of saying this one is x, this one is y. But when how can I distinguish this x and this x? Well, there is a way, and this is called cosine 30 degree and sine 30 degree. This is why we cannot use x, because if we write x, how can we distinguish from this x from this x? This is why we're using cosine and sine. Cosine for x and sine for y, and then we write cosine 45 degree and sine 45 degree, cosine 60 degree and sine 60 degree. All right, now there is a way to remember it. Again, I'm not asking you to memorize anything. I'm asking you to understand it, and then also use this understanding to find a shortcut. So what is the shortcut? This is 2, 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 and this is 2. And then I'm going to put 1, 2, 3. 1, 2, 3. And then I'm going to put 1, 2, 3. And I'm going to square everything. All right. So now what is this one? This is my cosine 30 degree and sine 30 degree, and let's prove that whether that's true. Let's prove that whether that's true. Now this one I have now let's find the sine. Let's find the sine theta. So sine 30 degree is opposite of rotation. So what is the opposite? Opposite is, let's say this is 1, because I have x is 1, so I'm gonna have the same right triangle. So this is root 3, this is 1, this is 2. Okay, and this is 45 degree, and this is 1, this is 1, this is root 2, and this is 1, this is root 3, and this is 2. All right, so this one is 30, 60, 90, and this one is 45, 45, 90, and this one is 60 degree. All right, so now let's check. Let's check. Let's check. So the sine 30. Sine is, remember, soka to wa. Soka. All right. So soka. So opposite over hypotenuse. So this is the theta, 30 degree. This is 30 degree. Opposite 1, and hypotenuse is 2. The cosine is Jason over hypotenuse. Jason is root 3, and hypotenuse is 2. So my cosine 30 degree is root 3 over 2. Let's see. Cosine 30 degree is root 3 over 2. Sine 30 degree is half. Sine 30 degree is half. Proof. Now let's say 45 degree, which would be opposite. Opposite would be 2, and the hypotenuse would be 2 square root of 2. All right, and the cosine 45 degree would be Jason. Jason would be 2, and the hypotenuse would be 2 square root of 2. Now 2 cancel, so 1 over square root of 2. 2 cancel, 1 over square root of 2. Now we have to do what we call a rationalize the denominator. So how do you do that? We multiply it by top and bottom. So now we have root 2 over 2. We have root 2 over 2. All right, so now this one is root 2 over 2, the cosine 45 degree, and the sine 45 degree is root 2 over 2. Root 2 over 2. What we can do by geometry, we can do also by trigonometry. But trigonometry gonna make our life so easy, because when the angle is not a 90 degree, we still can use trigonometry. How? So let's show you how. So this is the angle expanded by the first one expanded by 30. So 90 plus 30 is 120. And then the other one expanded by 45. So 90 plus 45 is 135. Other one expanded by 60. So 90 plus 60 is 150. So this one is 150. This one is 90 plus 30, 120. And this is 135. So now how can we do that? So this is 2, and this is 2. This is 2, and this is 2. This is 2, and this is 2. So this is, I'm going to write 1, 2, 3, and then I'm going to write 1, 2, 3, and I'm going to square everything just the way I did it over there. Now this one is plus and plus, so the cosine and sine, both of them plus. This one is, of course, minus and plus. So this one is minus, this is plus, this is minus, this is plus, this is minus, this is plus. What does that mean? That means that cosine 150 degree is equal to, and sine 150 degree is equal to, cosine 150 degree is equal to negative 3 over 2, negative 3 over 2, negative square root of 3 over 2, and cosine 100 and sine 150 degrees is 1 over 2. See how that makes our life easier. Now we can do, of course, around the circle. We can do around the circle. 180 plus 30 is 210. 210 plus 15 is 225. All right, and 180 plus 60 is 240, and this is 270, of course. So now how are we going to do that? So this one would be easy. So now we're going to do the same thing we did over there. So we're going to put 2, 2, 2, and 2, and 2, and 2. So this is 3, 3, 2, 1, and this is 3, 2, 1. Root. So we're gonna make this one negative, because this one negative and negative. So this is negative, 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 this is negative. Root 3 over 2. All right. So what does that mean? So for example, the cosine 225 degree and sine 225 degree. So cosine 225 degree is negative root 2 over 2, and sine 225 degree is negative root 2 over 2. Now